Welcome everyone to my LeetCode weekly contest 410 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be doing the contest live. We'll be answering questions and not sharing any code in the chat. So don't try to copy paste code. But we will share the answers after the contest is over. Only after the contest is over. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems, as well as hardest problem falls of previous contests. As usual, like and subscribe to stay up to date on new videos. Alright, we started the live stream a little late today. So I want to make sure, let me just check that the audio is fine. Real quick. Okay, sounds good. Alright, so I'm going to jump right in. You know, as usual, you guys will know, I have my coding on a different window because I want to make sure I don't share any code or share any answers. Oh, snap. I want to make sure I don't share any code or any answers on the live stream. Alright. Don't know if anybody is here. Yeah, for those who are here, welcome, welcome. I'm sorry I've been away from streaming for a few weeks. Yeah, unfortunately life catches up with you. But I'm back to my regular schedule. I hope to see more of you show up. So question 1. Snake in matrix. Okay. Okay, this is going to be a quiet chat today, unfortunately, because this is the first day I'm back. It is the first day I'm back, so I don't think a lot of people are watching. Hey, Surya Kiran. Welcome, welcome. Oh, let me make sure I share the right window. Yeah, welcome to the channel. Remember, if you have questions, ask in the chat. I will not share any answers live. No, I'm not a guardian, unfortunately. I'm still working my way up. And I hope that people who are also working their way up can find inspiration in what I do. Okay. Oh wow, this is a very desolate channel today. It's very unfortunate. It's been a while. So I get that why people are not coming. The usual subscribers and the usual folks are not showing. Yeah, that's a little bit unfortunate. All right, first question done. Well, I'm kind of glad that nobody's watching this live stream because man, I'm just back. I just got back, and I kind of want a sort of warm up live stream. So it's good to have no pressure and no one to have to cater to. So undirected tree with n nodes labeled 0 to n minus 1 rooted at node 0. You're given a 2D integer array edges. There's an edge between A and B. It's good if all the subtrees rooted at its children have the same size. Okay. Hi, welcome. I see that a few folks have joined the live stream. So if you have questions, make sure you ask in the chat. I'll try to get to you. Today is going to be a little bit quieter, so you would probably get more attention, which is good. It's also the first day I'm back. Oh, question 2, you're not given n. That's not good. Alright, it's not a big deal. This is a very, very quiet stream today. Huh. Hint for C? Let me see. Find count of monotonic pairs. So you're given an array of positive integers nums of length n. We call a pair of non-negative integers arrays. Let me come to the right place. Oh, actually I shouldn't do this. Yeah. Of non-negative integers AR1, R2 monotonic if the lengths of both arrays are n, and R1 is monotonically non-decreasing, and R2 is monotonically non-increasing. R1 plus R2I equals nums I for all 0. Count the number of monotonic pairs. So this looks like a dynamic programming problem. So basically there's n. You're given n. And n is a bunch of numbers. And then what you have is you have R1 and R2. And R1 is non-decreasing, so it's going up. And then R2 is going down. Right? So you can basically imagine, you know the value of these guys, right? So if you know the value of, the number at R1, you know the number at R2, right? So basically what you need to do is, I don't want to give out the solution, but basically it's a dynamic programming problem. So try to solve this problem if try to solve the problem for n equals to 1. What's the solution for n equals to 1? What about n equals to 2? And then n equals to some large number. So you can sort of solve it like dynamically. Yeah, so that's my hint for C. I hope that's helpful. Am I sharing the right screen? Yeah, sorry guys. I'm just back to streaming. So I'm still a little bit disoriented. Yeah, so basically you try to solve the problem for n equals to 1 first. If n equals to 1, how do you count the number of pairs? Right? And then n equals to 2, how do you count the number of pairs? Yeah, so I think that will work. I haven't done question 3 yet, so this is just my guess, and this is how I would tackle it. Yeah, and because you have this constraint that R1 needs to go up and R2 needs to go down, you also need to consider the number before. Right, when you solve for like n equals to I, you need to know what's the best number in I all the i's before. Yeah, so that will work actually. I think the sort of strategy I'm describing will work for question C, but I don't think it will work for question 4, because question 4, nums I can be very large. Nums I is up to 1000, then you probably cannot do that. If nums I is up to 50, it should be quite straightforward, I think. Yeah, so I don't know how to do question 4, but I'm still working on it. So do your best. Give it your all. Show me the answers. Yeah, there are no answers in this stream, so we don't show answers here until after the live stream. But if you want to, if you need help, just type in the chat. I'll try my best to give you hints. I won't be showing code. There's no code shared on this channel ever, and I also will not give like the whole deal away. I'll try to be subtle my hints. can you clearly give hints for C? I'll see if I can give a little bit more hints. So I'm still working on it, so I cannot give you the solution. And also generally, I don't give the whole solution in this channel. Basically what you want to do is to think of it as dynamic programming problem, right? So you want to start with n equals to 1 first. So your nums is very long, but you just pretend it's the first one, right? So let's say the example here. Let's say the example here is 2, 3, 2. 2, 3, 2. So your R1 can be 0, in which case R2 will be 2. Your R1 can be 1, in which case R2 will be 1, right? Back first. Yeah, if that is 0, right? So if R1 is 0, then what will 3 be? 3, sorry, let me backtrack a little bit. When n equals to 1, you look at only the first value of n. AR1 can be 0 and AR2 can be 2, right? That's a possible combination. This is the smallest number, this is the largest number, and no constraint because this is the first one. So if that's the case, what will be what are the possible values for 3? Well, the possible values for 3 will be, it can be 1. Sorry. Yeah, it can be 1, and it can be, if it's 1, then this 3 will it cannot be 0. It has to be at least 1. Yeah, because this number has to be 2. So now the number that you can put here depends on the number that you see before here, right? So in this case, this number has been larger than previous one. This number must be must be smaller or equal to a previous one. So this is the smallest number that fits, and this is the largest number that fits. Now you come back to 2, right? So for 2, the smallest number that fit is 1, and the largest number that fits is I guess this is 1 also. So you can basically count the total number. Yeah, and so the sort of trick is you can do this because the maximum value of nums is 50. So you can actually have a n by 50 array. You have an n by 50 array where you keep track of all the A1s. So you have an n by 50 array. You keep track of all the possible value of A1. If you know the value of A1, you know the value of A2, right? So you say if A1 is 0, okay, that's allowed. What is the possible values for, A1 second number, A1 third number, and so on and so forth. And you count all these things. Yeah. So that's probably as much hint as I'm willing to give for now. I hope that's helpful. Once again, sorry I'm a little bit sick, and also I'm still warming up back to streaming. I haven't done this in more than a month, unfortunately. Yeah, so I'm also sort of struggling a little bit to get back into the zone of things. So if I'm not explaining things well, I ask for your forgiveness. I will be better next week with a bit more practice. Yeah, so let's see. If you want hints for question 3, you can roll back the timestamp about 5 minutes. So I was talking about it just a while ago. So I need time to work on the contest also. Basically, in short, is question C is some kind of dynamic programming problem. You're trying to solve it for n equals to 1 first, and then you sort of go from there. So you want to have a DP table. I'm going to leave you to figure out the rest. Yeah, you need some kind of DP table where you store the count for each value of ARR1. Yeah, sorry, I can't share code. So no code is shared during contest, but we will go over answers afterwards. Yeah, so we can't share code during the contest. It's still contest what you might call it, integrity, right? So we want to make sure competitive integrity. So we want to make sure that there's no sharing of code. All right. Man, I'm actually super far behind. So I need to work harder and get this done. Huh, interesting. This is a real struggle today. Hint for 2. Okay. Don't spam. I'm gonna go over the answers. So don't spam. Okay, so 2 is basically a tree problem. Okay, so you have these edges. These edges help you construct a tree. And what you want to do is, after you construct the tree, you have to count the number of nodes whose children have the same number of descendants. So for instance here, this 3, 4, 5, and 6 have 0 descendants. These guys have 3 descendants, including themselves, and this one has 1, 2, 3, 4, 5, 6, 7. So I guess this one is actually 1 descendant. So at the bottom level is 1 descendant. So the first step is you need to actually construct the tree. So that's the easiest way. Just construct the tree. Step 1, turn this edge list into a tree. You want to define some kind of tree node class. And then the tree node class will help you find the children. After you construct the tree, step 1 is make tree. Step 2 is count children. For every node, count how many children it has. And then step 3. Step 3, what you want to do after you count all the children is you want to count how many good nodes there are. Yeah, so it's a 3-step process. I hope that's enough. Oh, yeah, I hope that's sufficient. Yeah. Yeah, I did discuss question 3. Sorry about that. Let me talk about question 3 again. I think question 3 is the one that people have the most questions about. I'm also not done with question 3, so unfortunately I can't help out that much. But basically, what you want to do is, what I'm trying to do is basically have a dynamic programming approach. Think about n equals to 1 first. How will you count the answer for n equals to 1? If this is if let's say your input is your nums is 2, 3, and 2, when n equals to 1, right? You look at n equals to 1, the first column. The smallest number a1 can be is going to be 0. Let me use a different color. It's going to be 0. This means that a2, the largest number that a2 can be, is going to be 2. When n equals to 2, the smallest number a1 can be is not 0 now, because it has to fulfill 2 constraints. One is it has to be larger than this or equals to this previous one, which is 0. And it also has to be big enough such that this number minus this number, this number minus this number is at least is at most 2. So a1 keeps going up, a2 keeps going down. Okay, so the smallest number that this can be is going to be 1, right? And then this will be I guess this is 2, and then you go on. When n equals to 3, the smallest number it can be is going to be 1, and then this is going to be this is going to be 1 also. So you can, if you think about it this way, basically what you want to do, you ignore a2, just ignore this, pretend this doesn't exist. You just find the smallest possible number you can have and the largest possible number you can have for the index in a1. Okay, and then you basically do some kind of dynamic programming. I'm going to be vague here because I don't want to just give all the answers. Yeah, you want to do some kind of dynamic programming and say, okay, when a1 column 1 is 0, how many answers I have? a1 column 1 is 1, how many answers I have? And so on and so forth. And so you probably, for question C, the nice thing about question C is that nums is smaller or equals to 50. So you can basically have a dynamic programming table with 50 rows. So it's doable. I don't think that works for question 4. So I hope that was helpful for people. So there's no code shared on this channel. There's no answers really. I'm not gonna share any answers ever. Not during the live stream. The answers will stumbling over my words because it's been a long time since I've live streamed. What we're going to do is we're going to give hints and we're going to discuss what the questions mean. And I'll try to help you guys along with words. But I won't give you any code. Yeah, I'm also really far behind, FYI. So it's been a while since I've done this. It's my first contest in more than a month. So I'm doing terribly. Man, this is so demoralizing. So if you're getting stuck or you're still working on stuff, don't worry, you're good. As long as you come back every week and you practice, you'll get better every week. Hey, Fury Nick! Oh, welcome back. It's been a long month. I was busy with a lot of other projects, so unfortunately I wasn't able to come back to the channel. I'm so happy to see a familiar face again. Welcome, welcome. Yeah. I actually have no idea how to do question 4. So I'm still working on question 3. So it's gonna be a while. Yeah. Fury Nick, have you been doing a lot of contests in the past month? Counts of pairs. Yeah. Oh, Code Force. Oh, wow. Code Forces. Yeah, Code Forces is more competitive programming style. LeetCode is more. LeetCode often have questions that will actually show up in the tech interview. So Code Forces is if you're like hardcore competitive programmer. It's not super helpful if you just want to pass a tech interview. But if you want to be an elite competitive programmer, then Code Forces is really the way to go. At least that's my impression. I haven't done a lot of Code Forces. All right. Still working on question 3. Yeah. Nice. I see more people in the live stream now. Welcome to everyone. Again, apologies that this stream is a little bit scuffed. It's my first time back in more than a month, but if you tune in next week, will be good. And even this week, I hope that we can have a gathering place for everybody to hang out and do LeetCode together, and yeah, learn together and have fun. Sorry, the stream has been very quiet. Let me see what's going on. Fury, any hints for C? Can you solve second without graphs knowledge? I don't think you can solve the second one without graph knowledge. Does third question need DP? I'm using DP. I don't know if you need it. Maybe there's an even better way without DP, but I'm using the dynamic programming solution. Actually, I think there's an even better way to do it than DP, because question 4 and question 3 are the same. Question 4 you cannot use DP. I think you cannot use DP because the size of nums I is too big. So I believe that there's yeah. Oh, AI is small enough to brute force it? Really? Huh. Well, we'll see how it goes. Yeah, I'm using DP for question 3. So if I'm really lucky, I can also use the same answer for question 4. But we'll see. If I'm really unlucky, then I cannot complete either question. So I'm surprised you can actually do it by brute force. I'm quite surprised. I equals to 0. Nums I 2. The DP is giving me a headache. But I'm pretty sure DP is the right way to go. Maybe DP will work for question 4 also. Or not. I don't know if it'll work. It seems quite suspicious. But it's really giving me a headache. Damn it. Dang it. Okay. Yeah, well, I hope you guys are having more luck than me. I'm really trying to see how to get this DP. The minimum number you can have. Okay. So in the second column, when the previous number, okay, let's say I have 0 for my first number. And then for my second number, the smallest number I have is going to be 1. It's going to be either 0, the larger of 0, or 3 minus previous max, which is 1. Okay. And then the maximum number I can go for the second number is going to be can I have 2? 2? If this is 2, then this will be 1. This will work. Oh, there's no max. Actually, there's no max. The max is up to 3. Max is up to 3. Which means that so when n equals to 0, the first number is 2. I have one combination when AR1 is 0, one combination when AR is 1, and one combination when AR is 2. Okay? When n equals to 3, when AR is 0, oh, so I see. Okay. So when this number is 3, the largest number I can have the largest value for 3 I can put here is 3. I can put 3 here. I can always put 3 here. But that's not going to be super great. But the smallest number I can have is going to be determined by this number here. Hey Rohan Sharma, welcome back. Yeah, I was away for a month. I've gotten really rusty, both in my streaming and also in my LeetCode contests. I hope you have been more consistent than me, and you're doing well. Good to see a familiar face again, Rohan Sharma. Huh. Dang, I'm really trying to see how to do this DP. So basically, I have the structure of the table, which is the number on the left tells me what is the last number in the sequence. So when n equals to 2, there are 3 possible, when n equals to 1, nums n equals to 2, there are 3 possible sequences, 0, 1, and 2. And then when n equals to 3, 0. Yeah, this is a tricky. Can I have 0? It'll be 1 and 3. It can be 2 and 2. Okay. So when, let's see. Okay, I think I got it. Yeah, did anybody solve question 4? I'm just out of curiosity. I hope somebody solves question 4. I wonder if it can be done using DP. A2 equals to nums I minus 1 minus A1. Okay. Nums I okay, so the smallest nums I yeah, very hard to maintain both the conditions. Are you talking about question 3? Yeah, I think I'm close. I hope I am. I'm doing DP for this. I think that's the right strategy. Okay. I think I have something. All right. I have something. Oh, damn it. I guess I don't. Yeah. Well, I hope somebody managed to do question 4. I'm rooting for all of you. MN not defined. Assignment out of range. Num0 plus I. Okay. TPI. Huh. Let's say can finish question 3 within the next 10 minutes. A2 equals to nums I minus 1 minus A1. A1 equals to J. Okay. Okay. I think I'm fairly close. Oh, sweet. I managed to do question 3. At last, just in time. God damn it. Let's see if this works. The same answer works for question 4. Probably not. But that's not gonna... Yeah, but we can try. TLE on question 4. Ah, so close. 547. Yeah, the fourth one, I think DP also works for the fourth one, I think. I'm not super sure. Do you also make videos on their solution after the contest is over? Sort of. So I have the VODs of my live stream, so you can always look at them. And what I do, I unfortunately will not do it today, but usually what I do is I will go over the answers for all 4 questions at the end of the contest. So you can always find answers for all the previous contests. If I get stumped on a question and I really cannot solve it, which happens quite often for question 4s, I will make a separate video. And then you can watch that at a later point. But that video might come out only, may take a week to come out. Because for the very hard questions, yeah, I don't know whether I can solve it that easily. Okay. Yeah, I don't know about question 4. Question 3, I managed to do it just in time. But question 4, I'm stumped on the really large numbers. The large values of n. Yeah, I don't think DP works for question 4. I'm not sure. If somebody knows the answer, just definitely let me know. But I don't think DP works for question 4. Okay, so the contest is almost over. I think I'm gonna give up on the last question. Those of you who are just trying, yeah, you're considering combinatrix. Yeah, I think so. You know, I don't know. I feel like there should be some combinatrix. I feel like if I print out the DP table, I'll be able to see the pattern. But yeah, I ran out of time. Anyway, for those of you who are around, I would appreciate if you like and subscribe to the channel. Come back next week and watch more. I stream every week. If there's a bi-weekly contest, I'll stream the bi-weekly. If there's no bi-weekly, I'll stream the weekly. The bi-weekly contest is a little bit better because it's the time works out better for me. It also works out better for many of you guys who are in the Eastern Hemisphere. As usual, you know, check out the rest of my channel if you're interested in LeetCode content. I would solve that. When I get stumped on the hard questions, I'll try to make a separate video and post it there. I also make videos on those daily problems as they come up, but probably not every day. If there are other type of contents that you want me to, if you want me to explore, please comment on my channel. I read and reply to all comments, so I will try to put out content that's interesting to folks. Alright, I'm going to take a sip of water and I'm going to come back and I'm going to see if I can discuss some answers for the first 3 questions. Be right back. All right. So the contest is over. My ranking is going to be really, really bad. But it's alright. You know, you live and you learn. I'm going to go through each of the questions one by one. But before that, let me read from my script. We are discussing solutions for LeetCode Weekly Contest 410. Jump to specific questions using timestamps in the video description. Please check out the rest of my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Also, it helps me out a lot if you guys watch my videos and also subscribe and like and, well, interact with them. So I really appreciate that. Alright. So, hang on, give me a second. Cat is here. Okay. So we're going to start with question 1. We're going to be super quick about it. I think question 1 is not super difficult. All you have to do is to follow instructions. You start with x and y equals to 0, and then, you know, whatever command it is, you just add or subtract 1 from x or y, up, down, left, right, and at the end, this is the only tricky part. Instead of returning x and y, you have to return what number it is. So how do you find this number? You just multiply x by the row size, and then you add y. So if this is the second row, x will be 1. So you multiply by that, you get 3, and y is 0, 1. So it's 4. Okay, that's it for question 1. For question 2, count the number of good nodes. Question 2. There's an undirected tree with n nodes labeled from 0 to n minus 1 rooted at node 0. You're given a 2D array. Basically, you're given an edge list indicating there's an edge between A, I, and BI in the tree. So a node is good if all subtrees are rooted and its children have the same size. So there's a few tricky things about this problem. The first thing is this data structure is always a pain. This edge list, I hate the edge list. The edge list is so difficult to work with. It's almost always to make this almost always better to make this an adjacency matrix, which is probably pretty much the first thing I always do. The second thing is the edge list is undirected, but your tree is directed. So, oh wow, I hate this. This is not good. So let's say this 0 and 2 have an edge, right? It can appear as 0, 2. It can also appear as 2, 0. This is an undirected edge list, and you know that in the problems, the sort of test cases they give you, they're going to flip some of these. So this is the second thing to be careful of. So what this means in total is that I did not take any shortcuts. I basically did this thing step by step. One, I turned this edge list. Let me see if I can bring up my actual solution. First thing I do is I want to construct First thing I do is I want to construct the tree from the edge list. So to do that, I turn this into a adjacency matrix, and then I start from node 0. So this is a very standard pattern that you use. You turn this edge list into a adjacency matrix first, and then you have some kind of like breadth-first search or whatever you want to call it. You have some kind of queue. You add the first node in, and then you just do a recursive search down, and that will help you create the tree. And what I did is I define a tree node class with children and like count. And once you've created a tree, once you've made the tree, the rest is not hard. The next step is to count the number of children in each tree, in each subtree. So that's very simple. You just do a recursive BFS or DFS, whatever you want. You count the number of children each node has, and then last step is count the number of good nodes. So this is the easiest step. You just, for each node, this is the easiest step. For each node, what you want to do is you want to check if it has no children, then it's going to be a good. The number of good is increased by 1. If it has at least 1 children, then what you want to do is you want to check all of the children have the same has the same size, right? So that's all you need to do. So this question is not super difficult. If I want to check the chat, which language do I use? I use Python, because Python is not a bad language. Usually you don't want to use Python for production. You want to use Java or C++. But the good thing about Python is it's really good for learning. So you're learning, or if you are actually, even if you're doing competitive programming, I just like Python. It's quicker for me. You can use whatever language you want. Okay, so question number 3. Count the number of monotonic pairs 1. Okay, find the count of monotonic pairs 1. So this is the first hard question. You are given an array of positive integers nums of length n. We call a pair of non-negative integers integer arrays R1 and R2 monotonic. If the length of both of these are n, R1 is monotonically non-decreasing. In other words, it keeps going up. And R2 is monotonically non-increasing, i.e. it keeps going down. And both of these things add up to I in every step. So let's draw this out pictorially. Let's say your nums is 2, 3, 2, 4, and let's say 1. Okay? So R1, one possible candidate for R1 might look like this. Let's say this one is 0. So R2, because R1I, R1 and R2 at the same index I, must add up to nums I. So when I is equals to 0, 1, 2, 3, 4. So when I equals to 0, nums equals to 2, nums I is 2, R1I and R2I must add up to 2. So if R1I is 0, then R2I is 2. Okay, you can also make this, you can also select 1 and 1. That's also valid. In fact, 2 and 0 are also valid. You can pick whatever you want. Okay, this is just an example of sequence that works. So let's say I pick a 0 and 2. So when I equals to 1, I know nums equals to 3. So R1 plus R2 at index 1 must add up to 3. So let's say R1 is 1, R2 will be 2. These two will be add up to 3. you see that R2 is still not is stays the same. It does not go up, and R1 will keep going up or stay the same. Okay, so the constraint is matched. What about here? Here I can maybe say 0. Oh, I actually cannot say 0 because I have to go up, right? 0, 1. The smallest number I have is 1. Okay, if I have 1, what happens to this guy? This guy goes down. So that's fine. 1 and 1 goes down. Okay, so I'm pretty sure adding more numbers here will result in impossible solutions. So this is an example. This is an example solution for R1 and R2 when nums is 2, 3, and 2. There are other example solutions. For instance, for instance, 0, 2, 2, 2, 1, 0 is also a solution. Okay, so these are both possible solutions. This red one is a solution. This orange one is also a valid solution. So your job is actually to count the number of possible solutions. You don't have to just. You cannot just. You're not just going to find one solution. You're going to find how many solutions are there in total. You have to count all of them. Okay, so how do you do that? Generally speaking, when I see a problem that has a very long array, my first instinct is to use dynamic programming. And if you look at the structure of this problem, you'll notice that at every index I, the only constraint I care about is the immediate previous index. So what I can put in this R1 and R2 at index 1 only depends on the R1 and R2 of index 0. So again, this should scream dynamic programming. Yeah? So that's how you know the best way to proceed. So the DP table that I construct looks like this. Okay, on the x or one axis, we have nums, and on the other axis, we have the value of R1, and if you know R1, you know R2. Actually, let me erase some of these so I make space for more interesting stuff. So we want to fill in this table. How do you fill in this table? So step 1 for the first column. First column is very easy. Whatever this number is, you just put a 1 in all of the values of R1 up to nums 0. So if in this case num 0 is 2, 0, 1, and 2 will have 1 each. Why 1? Well, if you think about dynamic programming, you're solving the problem for when n equals to 1. When n equals to 1, there's only one number in nums. What are the possible monotonic pairs? Well, there's one monotonic pair that ends with 0, one monotonic pair that ends with 1, and one monotonic pair that ends with 2. So 1, 1, and 1. Okay, so at 3, what will you do? If you look at the next number, what happens when nums is larger than n is larger than 1? Well, the trick here is to look back to the previous column. Okay, so when you're here, What are the possible options for 3? When nums I equals to 3, A1 can be 0, in which case A2 is 3. A1 can be 1, in which case A2 is 2. A1 can be 2, in which case 2 is 1. Can be 3, in which A2 is 0. Okay? Which one of these are actually allowed? Well, let's consult the previous column. In the previous column, we know that the previous column, ARR1 can be 0, 1, or 2, and ARR2 can be 2, 1, and 0. So, this one actually doesn't work. This one doesn't work because there is no value of this A2 here, this 3 will be larger than, and the smallest will be larger than the largest value in the previous column. So this one doesn't work. Likewise, this one also doesn't work. Yeah. Okay, hold on. Let me check my notes. Okay, sorry. Let me check my notes. Okay, yeah. Basically, so these are the 4 combinations of A1 and A2, right? So for each of these A1 and A2, you want to count how many of the previous combinations work for you. So in this in this previous thing, when R1 is 0, let me choose the red pen. When nums R1 is 0 and R2 is 2, 1 and 1, 2 and 0. Okay? So we know that this doesn't work because this A3 violates everybody. So this one works because it can match with this one. Let me be more intentional about it. So this one matches with this one and matches with this one. So 1 and 2 will have value 2 here, because there are 2 possible previous. Yep. 2 possible previous combinations. It's basically here and here. So 1 plus 1 is 2. So I know when the previous R1 is 1, I can have and the previous R1 is 2. Both of these will allow me to construct a new monotonic pair where the new R1 is 1. So likewise this one, 2 and 1. 2 and 1, well, this one works with here and here. So this one, 2, is going to be 2 again. And the reason why it's 2 is because this guy feeds into him and this guy feeds into him. And then 3 and 0, I don't know. I don't think 3 and 0 works for anybody. Actually, 3 and 0 works for everyone. Sorry. Yeah, 3 and 0 should be 3. 3 and 0 works because all of them work for 3 and 0. But you'll find that 3 and 0 actually doesn't work moving forward. So it's not going to be super helpful. Yeah. So you can actually continue this pattern. For 2, for index number 2, the number of sequences that end with 0 in index number 2 is actually 0. None of them work for this guy. For 1, it's going to be 1, and this is going to be 3. And once you figure out the whole table, you just sum up. You just sum up the answer here. And this is going to be 4. And that will be your answer. Yep. So I hope this was helpful. I hope this was helpful to people. So question 3 is really the one that is a little bit harder. The other two, question 2 is a bit annoying, but it's not too difficult. Question 4, I actually don't know how to solve it. I tried using the same dynamic programming solution. It doesn't work. So I might just look at what other people are doing, and I might post a video in the future. But maybe I won't. I don't know yet, depending on how useful it is to people. But let me check if there are any questions. If there are no questions, I think this is the end of the live stream. It's actually really late here for me. It's past midnight, so I probably have to go to bed soon. I don't see any questions. So this is the end of the live stream. I hope it was helpful. See you guys next week. Bye.